All right, what we're talking about today are special segments, and so that would be altitudes, medians, angle, and perpendicular bisectors. So let's get started with this. So first we're going to start with median. So a special type of segment is, one type of special segment is a median, and a median connects the vertex to the midpoint of the opposite side. So the midpoint means that side is congruent to that side, so it has to be opposite side. So CM is congruent to EM. Now, some questions you need to think about is, does it pass through the vertex? If it does, that's part of it. Does it pass through the midpoint of the opposite side? Yes. Does it form a right angle? No. All right, so those are some of the characteristics, but the main thing with the median, it goes from the vertex and it creates a midpoint on the opposite side. All right, so now we're going to talk about an altitude. So an altitude also is the vertex to the opposite side. However, this is important because it creates a perpendicular line. So when you have a perpendicular line, you're going to create a right angle. So this one, the important part here is the right angle. So let's look here. Does it pass through the vertex? Yes. Does it pass through the midpoint? No. But does it form a right angle? Yes. All right, the next one is a perpendicular bisector. So perpendicular we know is 90 degrees, and bisector means that it splits it into equal parts. So this is a perpendicular line that bisects a side. So it's just going to go here, but the important part is you have a right angle, and since it bisects, it makes two equal parts. So CM is congruent to EM. All right, so now let's ask ourselves, does it pass through the vertex? No. Does it pass through the midpoint on the opposite side? Yes. Does it form a right angle? Yes. All right, and then the last one that we're talking about today is an angle bisector. So this time you're taking the whole angle here and you're splitting it into two. So it connects a vertex to the opposite side and it bisects the angle. So angle CDB is congruent to EDB. All right, so let's look at this. Does it pass through the vertex? Yes. Does it pass through the midpoint? No, it does not say about the midpoint. Does it form a right angle? No. The important part here is that it bisects the angle. So the angles are congruent. All right, so what I want you to do is I want you to look at these angles here, and I want you to determine which special segment is shown for each. So I'll do a couple with you. So for this first one, we're going to look here. So right now, I'm noticing this line here. I'm seeing a right angle and I'm seeing congruent sides. So we want something that creates a right angle, two congruent sides, and it goes through the vertex. Well, that looks like, could be the right angle, it could be the altitude, right? Or it could be the bisector. So make sure you show here with that one, which one would it be? So in this case, it could say, oops, if it bisects a side and it's a perpendicular line, it could be a perpendicular bisector. All right, and then here, notice it is not equivalent. It does do here, and if you notice, this angle is congruent to this angle. So this one would be an angle bisector. All right, so make sure you're looking. Do we have this here? Do you have a right angle? Are your sides equal? So right now, I know as soon as I see that right angle, I'm looking at the perpendicular or I'm looking at an altitude. And since it splits it evenly, it is a perpendicular bisector. All right, go ahead, try the other ones. And then now we're going to go ahead and we're going to look at some of the examples. So RN is the perpendicular bisector of AT. Find x and find the length of AN and NT. So the important part with a perpendicular, we have a right angle, and bisector means it splits. All right, so I know this is going to be equal to that. So I put the equal sign here, I solved for x, and I got 7. And then now that we know x is 7, wherever we see x, we're going to plug that in. So I got 10 times 7 minus 20. So AN is 50. And then here for NT, we said we're going to plug in 7 there. So 5 times 7 plus 15 is 50. So NT is 50. So those are important things to look out for. So go ahead, I want you to do this one. And then for YB, this one's a little different. So you have to look here. An altitude, and the measure of angle YBZ is this. And we're going to find x and the measure of it. So we know with altitude, we're going to have a right angle. So let's look back. For altitude, the only thing that it does is just create a right angle. So I know we can use that to find the measure of any of the angles. So if it's the altitude of YBZ is this, I know it's going to create a 90-degree angle. All right, solve for that. X equals 16. Now to find the measure, we have to take x and plug it in to the value there. So then you'll get angle YBZ equals 90 degrees. All right, I want you to go ahead and try those. And then this last one is a median, since we haven't really talked about that one. For median, again, we're going to look at our notes. Median connects the vertex to the midpoint to the opposite side. So it's not necessarily 90 degrees, it's just to the midpoint. So if you have a median, I know this side is going to be congruent to that part. So you're going to take 6x plus 3 and equal it to 7x minus 1. And then once you got that, you have x. So the biggest part is just remembering, is it just midpoint? If it's the vertex and it's a midpoint, it's a median. If it's the vertex to a perpendicular line, it's an altitude, or perpendicular angle, excuse me. If it is perpendicular and midpoint, then it's a perpendicular bisector. And if your angle is in 2 equal parts, it's an angle bisector. All right, and that is special segments, altitudes, medians, angles, and perpendicular bisectors. Oops.